Welcome to All Things Data Science, the one-step channel to help anyone interested in learning or transitioning to data science, just like I did. Today we have another example from the LeetCode series, more specifically, the one that tries to find words that can be formed by characters. We'll get to that in a second. It's in the easy category, and specifically it tackles the problem of array, technically hash table as well. So here's the problem set. Let's have a closer look specifically at it. We are given two things. One thing is an array, and it's called words. So quite literally, an array with these words in it. And we're going to go ahead and call this, word 1, word 2, and so on. And then the other thing that we're given is this chars, and it's a string. I like to think of it kind of like the lookup pool, basically. And what we're saying is, as I go through my specific word 1, does C exist? Yes, it does. Does an A exist? Any A, right? Yes, it does. Does a T exist? Yes, it does. So this word is basically covered. Now, there's a couple of things. You could do the same thing about hat, as they tell us over here. H exists, A exists, T exists, the same thing. The whole word is good to go. I think some people get confused about each character can only be used once, so you could argue, well, we've got the T here and we've got the T here, but we only have sort of one T here. You could think of sort of a reset mechanism whenever you move to the next word. So that's okay, but within one word is really where this applies. And let's see, anything else that's usually confusing, I think, with others? Oh yeah, is really you can only use it once. Now, what does that also mean? So within the word, for example, if now I actually had instead cat with 2T, then we know that this one is good to go, this is good to go, this is good to go, but we only happen to have one T, so this would not be available, and so the whole thing would fail. So that's that with regards to the problem statement itself. Here is one proposal that I wrote, and then I usually do this where I say it's a meh solution, but it's actually pretty good, and it uses hash tables, which it seems to be, or like a dictionary, which seems to be kind of also what the problem set wants you to look at. But we'll have one that runs a little better, and I just think the usage and kind of the underneath idea behind it is interesting, so it's worth covering. So let's go here and look at what's going on this right-hand side. We'll do, for example, actually, let's also keep the description part next to us and dive in. All right, so a couple of things, right? At the end of the day, what do we actually need to return? Well, we actually need to return the sum of the length. So when we were happy with cat and hat, we need to look at how long those strings are and give a final total. So that's actually an int that we need at the end. So I'm going to at least set that to 0, and I'm going to use it at the end for what we need to return. For me, when I think of these problems, I think of a hash and sort of a dictionary. So I like to call it hash table. I used to do Java a lot when I first started in computer science. But anyways, hash table, dictionaries, sets would be where you only have keys but not values. But in this particular case, we do want a key and a corresponding value. So there's that. So not hash set, but rather hash table. So that's what you're looking at here. And basically, I go ahead, I fill the hash table with every character that we have in our chars. And the idea there is if it doesn't exist, so this is what we're saying, if I go look for my particular char, so here at index 0, that's going to be A, so if I look at A, I don't have it, I'm going to give it now a value of 1, and the key is going to be A, for example. But if it does exist, like when I encounter it at index 2, then I want to increment whatever I have right now with a +1. So it'll be 1 plus 1, and in this case, I'm going to have two 2's in that lookup hash table. I'll explain why we have this part here, and we have it sort of reversed over here in a second. So we keep on moving. So the first thing you want to do is go through your array of words, right? So that's sort of what's happening over here. But then you want to make sure now that you're at each word, you're going to go through each of it because you do want to look at every letter like we've seen before. So, so that's what's happening over here. I like giving my Boolean terms a very specific wording. So this one for me, I'm calling can be formed equals true. So i.e. as I'm looking at these words, you know, did I find anything like in BT over here, I will not find B. So can be formed is going to turn into false. And that's exactly what's happening over here is I say, as I'm going through, you know, my specific word, in the specific index, which is exactly what's going to happen here. At index 0, we have B. B is not in the dictionary that we formed. And therefore, I'm going to switch this and break out of the loop. And we're sort of kind of done with that particular word. Like bat or BT is going to be crossed out, where it's definitely not going to be added to that final sum. And then otherwise, you're going to keep on sort of looking for the next and the next. So now the importance of what I was talking about earlier is we're going to be modifying this hash table. So that's why we do need the one that's unchanged to not be touched. That's why I have a backup one. And what are we talking about here? So when I found the A over here, I want to make sure now I decrease my count from 2 back to 1. So 2 minus 1 is going to give me 1, and that's now actually what the value for the key A is equal to. So if cat, for example, had 3 A's, then that's not going to be a valid thing. Even though we do have A's in here, you need 3 of them, which is not a case that we have here, but that's where this comes in handy. And then finally, something super important is you're going to keep on going and kind of decreasing until forever. So, you know, we have 2 A's, like for example, for the lookup one, we have 2, and then we find one that we use for the cat A, so that becomes a 1, assuming we were in this one. Now we used up our second A, so we're going to get to 0. If we keep on going, we're going to start going to negative. So we do want to make sure to tell it, actually, the way a hash table works is if you hit 0, then that's like not having the element at all. So you just want to make sure to do that over here. And basically, yeah, once you're done with that specific word, because if we look at the indentation here, basically we're done with this for loop here, but we're about to move to the next word. So for that specific word, if this was never changed, then yes, I have confirmed that I can form my word based on my chars, and therefore, you know, the magical final bit, which is add that length to the kind of variable that I'm going to be calling at the end, and you sort of keep on doing that. And here, because you've been messing out with the hash table, you want to make sure to now get its original form back from your copied backup. So, so that's that for that one. And so if you run it, it gives you like a pretty decent solution, and that's why I didn't quite want to call it the meh solution, but I mean, it's good to be using hash tables. So now, however, I do think there's an interesting proposal in the discussion section, so I do want to talk about it, and you could have it over here, just so you can actually see it running, where it does a little bit better, and my assumption is usually if you use sort of innate Python things like already created methods and things like that, then usually that's more efficient. So that's my assumption there. But I like this idea of playing with counts. So let's have a quick look at what is going on here, and then we sort of wrap up there. So if anyone needs to jump off, that's absolutely fine because you've already seen the first solution. But if you're curious, then we'll have a quick peek here. So same story, right? You want to have what you're going to be returning, and that's going to be an actual int. So that one is still there. Now, the difference is going to be over here where we're still doing our little word loop, right? You have to, but then the kind of little trick they're doing is, yes, they're still looking at every character within a particular word we're in. So so looking at the C, the A, the T, and cat. But the difference here is they're gonna say, give me the word cat, and I want you to count specifically, and by index here I really mean kind of the character you're at, since we're not doing like a sequence of numbers instead. So here it's literally saying, give me how many times are you seeing the letter C, and that's going to give you something back. And for example, so this one is going to work out. So let's do one where it's not working out. So BT, for example, if you look at BT and you do a count of the word of the letter B, then that's going to give you a 1. However, if you were doing then for attach, which is your chars bit, then if you do a count of B, then that's going to be a 0. And sort of it's a little bit of a magical way, not quite, but you're kind of weeding out non-possibilities, right? So because 0 is smaller than 1, then this is kind of what I was calling earlier the I think not formed or something, or can be formed, becomes a false. So now you definitely know, well, obviously, if I'm looking for a B and you don't even have it in your chars, then we're definitely not going anywhere there. And therefore you break out just like we did last time. And otherwise, if it didn't change, so the can be formed is true. That's just a shorthand of doing that in Python. The statement itself is a true, therefore you could just put that in the if statement if people are not familiar with that. And yeah, otherwise you just kind of increment your last counter with the length, and you're sort of good to go. So hopefully that's also an interesting one. Thanks to the submitter. Let me go back to their name. And with that, we will wrap up, and you let me know if you have any questions or comments or suggestions for additional topics or problems to cover. And with that, until next time, thank you.